Hello again, everyone. Let's get started on part 2 of the videos I'm making today. Let's do our surface area. Now, in my opinion, surface area is harder than volume, okay? Surface area is just, think of what you would cover with wrapping paper. If you need to wrap a gift, okay, the area that you cover with wrapping paper is your surface area. You want everything covered, but you don't need to stuff it full of wrapping paper on the inside. That's volume. Okay, you don't need to worry about what's going inside. You just need to be able to cover everything outside. Now there's two types of surface area, as you will remember. There is lateral surface area. Okay, lateral surface area is just the outside walls, basically, okay, of this book, okay, of this book. My lateral surface area is just going to be here, 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 and here. Okay, it is not going to be the front or the back. Okay, neither of those will be part of the lateral surface area. It is just these lateral sides. This would be part of the total surface area. The bases, aka the bases, are part of the total surface area. Okay, now that would make sense to then say that the general equation, there may be some different equations for lateral area and for base area, but the general equation for the total surface area will be the lateral surface area plus 2 times the base area, okay? Because we will typically have 2 bases. Now that is for prisms. If we have a cone, okay, if we have a cone, it will not be the same. We will have something else for a cone. Same for a pyramid. But for prisms, like, well, spheres are totally different. But for at least these two and a few more we'll do, this is always what we're doing. We're just doing the lateral area, the lateral surface area, plus the area of 2 bases. Okay, the 2 bases. Now let's move over to a sphere, and let's actually start thinking about this in practicality. Now spheres are unique in that they don't have a difference between a lateral surface area and a total surface area, because they're all lateral surface area. They don't have a base. A sphere doesn't have a base, okay, to add on. There's nothing that you would have that's not on the lateral sides. Okay, so there's only one type of surface area for a sphere. And spheres have one of the easier surface area formulas. Theirs is just 4 pi r squared. You will notice that is just 4 times the area of a circle. Wow, because the area of a circle is pi r squared. It's 4 pi r squared. Now in this one, you'll notice we do not have an r. We do not have a radius. We have a diameter. We have a diameter because it's going across the whole circle. I want half of the diameter. I want half of the diameter to be my radius. Half of 4 is 2. I don't know why I put up 4 fingers. Okay, half of 4 is 2. So I'm going to now fill this in. 4 times pi times 2 squared. Okay, that will be my total surface area of this sphere, and I'm going to keep pi involved. I do not want to get rid of pi. I have 2 squared is 4. 4 times 4 is 16. So let's just call our answer 16 pi, and I'm going to use meters squared because it is still area. It is still a 2-dimensional thing. It is still just 2 dimensions that are being multiplied. Okay, the radius is being squared. We are not going into a 3rd dimension. We are just doing surface area. Okay, that's it. That's the surface area of a sphere. It's going to get a little trickier for these other shapes. This one's great. This one's a square prism. Okay, our base, as you can see, well, no. Okay, I lied. It's still a rectangle. Okay, because this base is a rectangle. This base is a rectangle, and then it has the height, the depth of 5. Now here's a trick I'm going to give you for lateral area. This works for most prisms, pretty much all prisms, and cylinders. This works for it. It's not the case for cones, spheres, etc. Okay, but just like how we took, for volume, just like how we took the base area times the height, that said that, like when I had the books, the top books area times however many books there were was the volume. This is that idea of the perimeter, the border. If we find I cannot talk today, the perimeter, the border, and we multiply that by the height, we just have that outside shell, that outside husk. we just have those outside pieces. We have not accounted for what fills in the base and the bottom base. We've accounted for that outside husk. Okay, so let's do that. Let's find the perimeter. Let's find the perimeter of this top rectangle base. Let's multiply that by the height, and then we'll have our lateral area. Then we'll just add 2 base areas to it. All right, so our perimeter is 2 sides that are 4, that gives me 8, and 2 sides that are 5, that gives me 10. So my total perimeter of this base, my perimeter is 18. So if I take my perimeter, 18, and I multiply it by the height of 5, okay, the height of 5, I'm going to have 90. Okay, my lateral surface area, just these 4 sides, this wall, the wall that's looking at us, this wall back here, okay, and the back wall, all of those together are going to make 90 centimeters squared. Okay, now let's think about what the area of this actual base would be. This base's area would be 4 times 5, which is 20. How many of those bases do I have? I have 2 of them. I have one up here and one down here that needs to be covered with the wrapping paper. Okay, so it is going to be 20 for one base, 40 for 2 bases. 20 times 2 is 40. So my base area times 2, I'm just going to say is, okay, 40. I can now add these together, and I will have a final answer for my lateral surface area of 100, my total surface area of 130 centimeters squared. All right, next one. We're going to do the same principle for this one. We're going to find the perimeter, multiply that by the depth, and then find the 2 bases. Okay, so the perimeter here, 6, oh look, it's a square. This is a square prism. Okay, 6 plus 6 plus 6 plus 6, 6, 12, 18, 24. Our perimeter is 24. Okay, our perimeter is 24. 6, 6, 6, and 6. Our perimeter is 24. We now multiply the perimeter by the height, which is 3. 24 times 3 is 72. So our lateral surface area, just this wall over here, this wall facing us, the wall back behind us, and this wall to the side, those 4 walls total an area of 72 meters squared. Now let's find our 2 bases that we must cover. We must cover this top base up here, which is 6 times 6, and there are 2 of them. If 6 times 6 is 36, we have 2 of them. So 36 times 2 is, coincidentally, again, 72. Okay, so I need to add these base areas and the lateral area, giving me my final answer of 144 meters squared. Great. Okay, now the cones. I love the cones. Cones are super easy. I think cones are my favorite of the surface areas. Okay, because our lateral surface area for the cone, the lateral surface area is as simple as pi times the radius times the slant height. Okay, S. The slant height is the slanted height. I know, crazy. It's the height of the slant. It is not this height. It is not this height. It is the height of the slant. Okay, so I have the lateral area, the lateral surface area is R times S, the radius 8 times the slant height of 17.9 times pi. Okay, because I want to leave pi in there. So we have 8 times 17.9. That's a calculator one for sure. Eight times 17.9 gives us a lateral surface area. That is all of this around the cone, not including the bottom circle. Okay, a lateral surface area of 143.2 pi centimeters squared. Now, unfortunately, we're not quite done because we also have this base area, but that is easy. That is very easy. Okay, the area of a circle is pi r squared. Our r is 8, so we just have 8 squared pi, which is 8 times 8 fell on the floor. You picked them up and there was 64 pi. We now add these two together. If we add these together, we finally have the total surface area of this cone, which is 143.2 plus 64 is 207.2 centimeters squared. Good work. We are almost done with this one. Well, this assignment, not that problem. That problem's done. The problem's all done. All right, let's do 7 and 9. I'm gonna go back so I can make all of them show up in one image. But let's do 7 and 9 and call it a day. I think you will all be very well set for this test. Assuming you've been doing your work and watching the videos, which may be a stretch for me to assume. Okay, I'll be right back after I move the screen. All right, let's finish this thing up. So this one is tricky looking. Yes, it is scary. This is a pyramid, okay? So let's not get too worked up on what the formula would necessarily be here. Let's just focus on what we're going to do. I want to know the area of every side. So what if we start with the side that is the most repeated, which would be these 3 walls, these triangles that make the 3 walls. Let's start with finding the area of one wall. Okay, let's find the area of one wall. Multiply that by 3 for all 3 walls, and then add the base of this bottom triangle, which is the only one that will be different. Okay, so these side triangles, we can see a base of 3 and a height of 2.2. Notice the base of all 3 is 3. The base of all 3 is 3, okay, and the height of all 3 side walls is this 2.2. So if the area of a triangle is 1/2 base length times the height, we would have 1/2 3 times 2.2, and this we would have to multiply by 3 because there are 3 of those triangles. Okay, so where did I put my calculator? 3 times 2.2 should be 6.6, I think. Yes, 6.6 divided by 2 is 3.3. Okay, so we barely, not much. Divided by 2 is 3.3. So we have 3.3 as the area of each triangle, 3.3 yards squared, but I have 3 of them, so I must multiply that by 3 to get 9.9. Okay, times 3 gives me a total lateral area, a lateral surface area of 9.9 yards squared. That is not the final answer. We must also add to that the area of this base, this bottom triangle. It's the same thing, it's the same shape. It's 1/2 base times height. The only thing that changes is this height, okay? So we just have 1/2, 3 times 2.6. 3 times 2.6 should be 7.8. Yep, 7.8, so this bottom triangle is 1/2 base 3 times height 2.6 gives me 1/2 of 7.8 is going to be 3.9, I think. Yep, 3.9. So this bottom triangle has an area of 3.9 yards squared. We want to add these together, okay, and we will get 13.8. Okay, these will add together, and we will get a final surface area of 13.8 yards squared. All right, hey, time for an easy one. Ish, kinda. All right, so here, we're going to use the trick we used for prisms. This is a great time to use the trick that we used for prisms. This is the exact same thing as the one earlier, ain't it? Didn't we do a circle with a diameter of 4 already? Am I taking crazy pills? I need to go check, because I'm pretty sure we already did a circle with a diameter of 4. Okay, anyways, back to this one. All right, we have our perimeter of one of the bases. Identify the bases by being what shape you see congruently twice. We see this shape twice congruently, okay? I feel like I also did this one already, but whatever, not the point. Okay, we have the perimeter, this side matches here, of 3 plus 4 plus 5. Our perimeter is 3 plus 4 plus 5. So our perimeter is 12. Okay, that perimeter, that border, will be multiplied by the depth. Okay, perimeter times the height. That is going to give me 84. Okay, 7 times 12 is going to be 84. Okay, so our lateral area is going to be 84 meters squared. However, we also have two triangular bases we must include. 1/2 base times height for each triangle. 1/2, 3 times 4. 3 times, hold up, let's show you a trick. I have 1/2 base times height, and I have two triangles that will follow that formula. Well, if I multiply the 2 into this formula, it cancels out the 1/2. So realistically, finding the area of both bases at once is just base times height. 3 times 4 is 12. That 12 covers both triangular bases. So I will add that up here to the 84, giving me a final answer of 96 meters squared as the surface area of that prism. I'm going to use my little clicker, and I'm going to find out if I'm taking crazy pills. We already did number 9. We already did number 9. That was number 1. We're not doing it again. Okay, that's crazy to me. Sorry that I made you do the same problem twice on that homework. I did not notice that until now. Okay, but lucky you. Problem's so nice you did it twice. We got our last one, number 10. Then you will be set going here. This is again a cone. We are again doing a cone. Cone is one of the obscure differences from prisms or even pyramids. Pyramids, we are able to just logically brute force our way through. You can't really do that with cones. You got to remember that it is the lateral area of pi r times the slant height plus 1 base, so pi r squared. Technically, this is the formula for the total surface area of a cone. Let's begin with just the lateral portion. Let's begin with the lateral area portion. Pi, well, I'm going to phrase it as the radius, 13, times the slant height of 29.1 times pi. Okay, let's do that. 13 times 29.1 is 378.3 pi. 378.3 pi. We are going to add to that pi r squared. Fortunately, I know that 13 squared is 169, so I just have 169 pi. Okay, because that is 13 squared. I will now add these together, giving me a grand finale to this assignment of a final answer, 547.3 inches squared. That is the total surface area of that cone. Alrighty, that is it for the geometry videos for the next few days. I will make another one for the test review. You guys are doing great. I'm so proud of your progress. Keep it up. And I will see you on Tuesday.